Today, I want to talk about something most people in technology never think about. The internet feels massive, it feels resilient. Billions of devices, millions of servers, thousands of companies. But parts of that entire system depends on something surprisingly fragile. Tiny pieces of software maintained by a handful of people. Sometimes just one person. In early 2024, a single developer almost gained access to millions of servers across the internet. Banks, cloud infrastructure, enterprise systems, government networks. And the disturbing part is, he didn't hack them. He didn't exploit a firewall. He didn't break in encryption. He simply contributed code. And it almost worked. When most of the people think about internet, they imagine massive infrastructure, companies like Google, Amazon, Microsoft, huge data centers, entire teams of engineers maintaining everything. That's the assumption, but the reality is very different. Much of the internet actually runs on something far smaller. Tiny open source libraries. Modern software isn't written from scratch, it's assembled. Developers build applications by combining small reusable components. Encryption libraries, networking libraries, compression tools, authorization modules. Some of the most critical ones include OpenSSL, OpenSSH, curl, Z-library. These pieces of code quietly power the enormous part of internet. Most people never even see them, but without them, modern infrastructure simply wouldn't work. And here's where things get interesting. Every modern application depends on layers of other software. Your application uses a framework. That framework uses libraries. Those libraries use even smaller dependencies. And those dependencies rely on more code underneath. So one application can easily depend on hundreds or even thousands of external packages. One application, 1,000 dependencies, which means every system we build relies on code written by people we may never meet. Some of those dependencies become incredibly important. Libraries like OpenSSH, OpenSSL, curl, Z-library, and a compression tool called XG. These tools are embedded deep inside the operating system. They ship with Linux distributions. They run on servers all over the world, and most users have absolutely no idea they exist. But they are everywhere. Here's the uncomfortable part. Many of these projects are not maintained by large teams. They are maintained by volunteers, people working at night, on weekends, often unpaid. One developer maintaining software that millions of systems rely on. That imbalance creates a serious risk because something goes wrong in that code, the consequences spread everywhere. We have seen this problem before. In 2014, a vulnerability called Heartbleed was discovered in OpenSSL. At that time, OpenSSL protected a huge portion of encrypted internet traffic, banks, cloud services, government websites, and the entire project was maintained by two developers with about $2,000 in annual funding. Two developers protecting the encryption of the internet. When the vulnerability discovered, millions of systems had to be patched. That incident exposed something important. Critical infrastructure was being maintained with almost no resources. Attackers understand this weakness. So modern cyber attacks target the software supply chain. Instead of attacking the servers directly, attackers compromise the software those servers rely on. SolarWinds, CodeCov, 3CX, and in 2024, an attempt involving the XC compression library. Each of these attacks follows some logic. If you compromise a dependency, you compromise everything that depends on it. The XG library is a small compression tool. Its job is simple. It compresses files to make them smaller. But over time, it became widely adopted. It ships with many Linux distributions. It runs on servers across the internet. For years, it quietly did its job, compressing files, running silently in the background, maintained mostly by a single developer. And that's where the story takes a turn. Instead of attacking the system, the attacker targeted something else: trust. A new contributor began submitting patches, helpful improvements, bug fixes, code cleanups. Over time, they become a trusted member of the project. Eventually, they gained maintainer access. And once that trust existed, they were able to insert something malicious, a hidden backdoor. The backdoor was extremely subtle. It was hidden inside the test files, binary assets that most developers rarely inspect closely. During the build process, Those files unpacked hidden instructions. Instructions designed to interfere with SSH authentication. It deployed widely. The attacker could potentially log into the affected systems remotely. Millions of servers could have been exposed, and the attack might have succeeded, if not for something incredibly small. A Microsoft engineer, Andre Freund, noticed something unusual. Logging into server was slightly slower than normal. Not seconds slower, milliseconds. About half a second. Just 500 milliseconds. That tiny anomaly triggered an investigation, and that investigation uncovered the hidden backdoor before it reached major production releases. Sometimes the difference between security and disaster is just half a second. The internet feels massive, but parts of it depends on something surprisingly fragile. Code maintained by one person. The lesson here isn't about just one attack. It's about the structure of modern software. The internet isn't held together by one company or a single platform. It's built on layers of small projects, open source libraries, maintained by developers all over the world, often quietly, often invisibly, and sometimes by just one person. Which raises a question every technology leader should think about. Who is actually maintaining the infrastructure we depend on? Because the stability of internet might depend on them.